All right, welcome. Thanks for joining us. So I'm Jim Scharf. I'm the general manager for Amazon DynamoDB, and I'm excited to talk to you about some new capabilities that we just launched today. Quick show of hands. How many of you are current DynamoDB users? Oh, good amount. Well, for the rest of you, I hope you'll hear some things that might make you interested in trying out DynamoDB yourself. And we have a free tier, so there's really no downside to going and trying out DynamoDB. So before going into DynamoDB, I just wanted to kind of take a bit of time and talk about the history of Dynamo, where it came from. So back around 2004 is about when I joined AWS. And at that time, in December of 2004, the Amazon retail website had an outage. It's a multi-hour outage, and it was pretty impactful because, as you probably are aware, for retailers, December is a pretty important month of the year. And moreover, this was a time where e-commerce shopping was still kind of getting acceptance by the broader population. So it was a really big deal for Amazon. And once they got the site back up, they went and did a root cause analysis, and they learned that basically the root cause was failure to scale in the relational database stack. And what we came to realize is Amazon was using relational databases at a scale that at that time was pretty unprecedented. And with the projected growth of Amazon, we realized just continuing to scale the old way just wasn't going to work. So a bunch of senior leaders across the company met, and a number of top technologists, including Werner, went off to build a new solution. And what they came up with was a highly available key value store that originally was just used to store items in the shopping cart. So as you're purchasing on the Amazon retail website, obviously if we're losing stuff in the shopping cart, it's inhibiting your ability to buy, which is bad for us for a business and bad for you as a customer because now you have to go restart, right? And so we put that out, and it was highly effective for Amazon. And then we published in 2007 the DynamoDB paper, which kind of has become one of the seminal works in defining what we now refer to as NoSQL. And then kind of in a parallel track, the Amazon Web Services business was really starting to take off. And like we have done on a number of instances, we took a look and said, hey, Amazon Web Services customers might also benefit from this technology that we built for Amazon. So in 2012, we launched for Amazon DynamoDB. And then in the intervening years, pretty much all of Amazon properties in one way or another depend on DynamoDB. Things like obviously the retail website and Prime and Marketplace, and more recently things like Alexa. And just giving you kind of a feel for like the real implications, the kind of so what, like in Amazon, I was one time on a call where they thought that Dynamo was having issues. Now, it wasn't actually Dynamo. It was how they were, their app interacting with Dynamo. And it was a fulfillment center app. And in the background of the call, there was a guy screaming saying, hey, Joe, where do I stack all these totes? So for those who don't know, the fulfillment centers, they put your stuff in these totes, and they go at pretty fast speed through the fulfillment center along the conveyor belts and before they box them up. And the point there is, DynamoDB just has to be up for all sorts of real-world applications. Otherwise, they would literally have to stop the conveyor belts in the fulfillment centers. And so what does that mean to you? DynamoDB has been tested under some pretty extreme conditions, pretty extreme load. And things like Prime Day for us is a major shopping day of the year, Cyber Monday, Black Friday. And what that means is it's already been battle hardened, so you can know that it can meet your need for your application. And today we're happy to say that we have over 100,000 customers using DynamoDB for critical applications. We're doing well over a trillion requests per day processed. And we have single tables that are receiving millions of requests per second, and we have some tables over, in the hundreds of terabytes of scale. So the point being is, we have scaled this pretty far, and we're pretty confident we can meet your needs. And so today we're excited to announce a couple new capabilities. One, hopefully you've heard about DynamoDB Accelerator, or DAX, and we're going to do a deep dive through there, and Joe is going to talk through that and show a demo. And then also VPC endpoints for DynamoDB, which is a really important security feature. Okay, so how many people took a lift to the event today? I did, so a few people. And so, looking at the kind of real-world applications of customers using DynamoDB, I got in a lift yesterday from our Palo Alto office to come up here to prep for the event, and the Lyft driver says, "Oh, you work for Amazon?" And then he turned to me, he's like, "Do you know that Lyft is powered by AWS?" And I was like, "Well, yeah, I've actually worked there for 12 and a half years. I do." And we kind of engaged in a conversation about how DynamoDB is a database that's used behind all of the ride tracking and all that kind of stuff. And so it just kind of gives you a feel for whether it be Expedia, or if you're watching MLBAM, does some pretty interesting StatCast stuff on baseball. Just a very wide range of customers. And you can see the scenarios that we really get a lot of traction with are mobile, ad tech, IoT, gaming. These are ones that all come to Dynamo because of the huge scale, global presence, and consistent performance. And the other thing to think about is not just kind of the new age companies doing this, but increasingly even traditional enterprises have mobile and IoT use cases. Whether you're talking about farm machinery or banks or what have you, more and more these types of customers are also using DynamoDB. So as we sit down within the team and talk about how we're going to prioritize our investment to continue to grow DynamoDB, these are the main pillars that we think about. Security, performance, scalability, availability. These are kind of table stakes for any AWS service. We certainly think so. Hopefully you do as well. But in addition, one of the major reasons people come to DynamoDB is because it's a managed service. And so I'm going to talk a little bit more about that. And then lastly, Werner ended his keynote this morning saying go code. And so really we want to make DynamoDB a very compelling developer platform, easy to integrate with, easy for you to build awesome apps. So you use us for the database, and then you can innovate on top of us. So I'm going to talk through some of these as we go. So scalability. So we talked about we already have large tables and high request rate tables. The important thing you need to think about is you want to have a database that can react to rapid swings in scale, right? I mean, that's part of the cloud. Hopefully I'm preaching to the choir in terms of the elasticity is one of the major compelling characteristics of the cloud. And so you see here a real graph of a customer seeing 300% spikes from baseline. And what's important to think through is in this, if you were managing your own database, you need to worry about, oh no, provisioning, doing capacity planning, provisioning hosts, even if you're using EC2, that's easier, but you still have to spin that up. Perhaps manually resharding data across the new hosts, dealing with replication, HA, node failure, this kind of thing. And then also things like security patching of the OS and the database. That's all your responsibility. And it might be a little stressful, particularly if you're seeing spikes like that, to be thinking through all those things. And with DynamoDB, we take care of that for you. It's with as simple with a few clicks in the AWS Management Console or some API calls. A number of customers actually have, as part of their applications, they make some calls, scale up the table, do some batch processing, and then at the end scale down the capacity. And we take care of all that for you. And another real-world example here is Game 7 of last year's World Series. As they made the last out, the Cubs, made history by winning the World Series finally. And we had real-world implication here that we were watching DynamoDB. One of our customers, a social media type customer, they saw their traffic to their DynamoDB table increase by 500% in just a couple seconds. And they were crossing 3.5 million requests per second on a single table. Dynamo ran fine, their app performed well, and everything was good. But this is the kind of thing that customers have come to depend on for DynamoDB. So then, performance. So it doesn't matter, if we can handle the request, but all of a sudden the latency degrades terribly, because your application will effectively be down to your customers anyway. And so you see this graph here. The blue line is effectively is the request rate, and that's basically on the order of millions of requests per second. And the second y-axis and the green line shows the latency in milliseconds. And basically what the point of this slide here is, even despite large swings in request rate, Dynamo, for most customers, for most applications, Dynamo customers see very consistent single-digit millisecond latency. And that's really important, and that was core to how DynamoDB was built. But some of our most most advanced customers who are really performance-centric, while millisecond latencies was good for yesterday, they're really looking for microsecond latencies today. These are applications like ad tech, where you may just, in the ad tech industry, you may just have a few milliseconds, may determine whether you win the bid or not for placing an ad. And that that equates to real money, either won or lost for your business. And for these types of customers, we noticed a common pattern. They walked us through the steps they had to go through. They basically first had they decided to add a cache in front of DynamoDB for the most recently accessed data. And it was a good idea, but they walked through the muck they had to walk through. They first had to decide, well, which cache should I use? They had to learn the new APIs to that cache, and they had to figure out how they're going to lay out the data in the cache. They had to change their code around substantially to now hydrate data from DynamoDB into the cache, read from the cache when it was there, read back to DynamoDB when it wasn't, evict data out of the cache. And while it's all doable, and some of our most advanced customers did, it's a lot of heavy lifting. And then also they had to worry about just physically managing the cache, spinning up the EC2 instances, doing the deployments, worrying about HA, and scale, node failures, et cetera. And again, they're happy with the better performance they were able to do, but it was a lot of heavy lifting. So we asked ourselves, what if DynamoDB just had kind of a turbocharge button where we could give customers even better performance for the most recently read data? What if we could do that by just providing them an endpoint and with no API changes to their application, the DynamoDB compatible API? And what if all the nodes and HA for that cache were completely behind the scenes? It's not something they had to worry about. What if we could manage that for them? And that's what led us to build DynamoDB Accelerator, which we announced today is in public preview. And with that, I'm going to call up Joe, who helped build DAX, and he's going to give us a quick demo.
Sure. Thank you, Jim. All right, so with DynamoDB Accelerator, I would like to show you a little bit how this works through a demo application. It's one thing to look at the slides, but it's a whole nother experience to see it in action. All right. All right, so I've created a sample application ahead of time. Let me just open that up really quick. And what this application does is I have a DynamoDB table that I've already provisioned, and it's about 4,000 or 5,000 IMDb movie titles that contain the year, the date, and some information about each of these movies. And what this application does is very simple. Creates a DynamoDB client, instantiates a table for that particular client. We'll go grab this data from the movies table, and then it's going to do 10 iterations of 1,000 requests, and it's going to print out the average latency after each iteration. Right, and we'll compile for good form. And then we're going to run our application. Right, and we can see, just as Jim said, DynamoDB is experiencing single-digit millisecond latency. And for many applications, that's fantastic. But as Jim was saying, what about the applications in which literally every millisecond means something material to my bottom line? It's either the differentiation between my application and my competitors, or it's just I didn't get the bid in time, or it wasn't a good enough bid to be able to complete the sale. What do those customers do? So, at this point, if we want to add that cache, now is the point where we'd go, okay, well now, what do I go look for? Is it Redis or is it Memcache? Am I going to go spin up an EC2 instance, do wget, start playing around with it? We'd go back to our application and we'd start performing heart surgery on all the database calls to DynamoDB, right? We'd have to start wrapping those in this logic that basically says, hey, is that item in Dynamo? No. Okay, well, is it in the cache? No, let's go fetch it from Dynamo. Okay, we got it. Let's go put it back in the cache. And we have to handle that whole logic. So I've already provisioned a DAX endpoint ahead of time, and I'll show you how to do that in 1 second. But I'm going to show you how easy it is to add that DAX endpoint to our application. And then we just get seamless integration with DAX. And why is that? Well, DAX is API compatible with DynamoDB, which means the same interfaces that are exposed from the DynamoDB client, get item, put item, scan, query, update item, delete item, are exposed to DAX too. So we don't have to change any of that logic in our application. We just have to make the calls. All right, so let's go back to that same application that we had. And what I'm going to do is I'm going to comment out the DynamoDB client, and I'm going to remove some of this code. And this is the endpoint for the DAX cluster. And again, this sits in line between our client application and our DynamoDB tables. And then I'm just going to add this to a config that I'm going to pass to the DAX client. And as you can see, I didn't go change any of the rest of the code in my application. We're going to do the same get item test. We didn't change any of the APIs in our application whatsoever. And we're going to save this, recompile, and run it again. All right. So what we should expect in this application is the first time we do these gets, these are going to be all cache misses, right? Because this item wasn't in the cache before. And now when we start warming up the cache, those iterations, those 1,000 calls that we're going to do for the second, third, fourth, and fifth iterations, those are all in cache. So we can see, 5 milliseconds is really cool. 200 microseconds is awesome. That is fast. We just added in-memory caching to our application. Didn't have to write any cache invalidation logic. So let me go show you now how we would provision such an endpoint like this. So as many of you are familiar with, quite a few show of hands that have been using DynamoDB, this is the table that I was just playing with. We have the movies table and has the items. Right, and we have some goodies in here, some old ones, and half of these movies I don't even know, but there's some good ones in there. So this is the data we're playing with, and we said, hey, that's great. Now let's figure out how we're going to deploy this endpoint. So we go into the DAX console, which is just sitting right below DynamoDB, and you can see we have the preview tag, as we just announced that today. And we're going to go create a cluster, and we'll just call this SF Summit 1. And then we're going to choose the node type that we want. And what this really means, for your application is how big do you want your cache size to be? We're going to start off on the R3 instances, so range anywhere from 15 gigs to 244 gigs of memory. And what customers typically think about this is, what is my working set and how long do I want that to fit in memory? So we'll say an R3 large is sufficient. We'll choose, we have the ability to choose up to 10 nodes. We'll choose 3 for the purpose of this application. And then we specify a role. And what this role does for you is it says, hey, I'm going to let DAX call DynamoDB APIs on my behalf. And it also allows you to attach a security policy that says, hey, I only want DAX to be able to talk to these 3 tables and call these 3 APIs. Maybe it's just get, put, and scan if that is applicable to your application. Or it could just be the read APIs. We'll keep the same we'll keep the defaults for the subnet group and the security groups. And then we just click launch. And what this will go do is create an endpoint. Now, I've already created some of these ahead of time. I created a gym cluster earlier, but we'll grab the demo one that we used earlier. And we would just go grab this endpoint, and then we would go back to our application and add that endpoint in there with the DAX client, and we're off to the races. So if you could switch back to the presentation, please. All right, so as we talked about, DAX is a fully managed, highly available caching cluster. And what does that mean? What does fully managed mean? It means you don't have to manage any of the life cycle as you come to expect from an AWS service. All the patching, upgrades is handled for you. High availability is achieved through enabling to create clusters that have nodes and multiple AZs. So in the unlikely case that there's an issue with a node or an AZ, there's still 3 nodes, for instance, in a 3-node cluster. There's still 2 nodes that enable your application to keep moving along. And DAX also enables you to scale that out. So say, hey, 3 nodes isn't good enough for my application. I need millions of requests per second. You can keep scaling out 4, 5, 6, 7, up to 10 nodes for an individual cluster. We can scale that back down as well. With DAX, we're also integrated into the AWS services that you're used to using. For manageability, DAX will come out of the box with tagging, CloudWatch metrics, and console support, as we saw. And also for security, you manage DAX control either DAX's access to DynamoDB or your client's access to DAX through using IAM policies. And one of the questions we typically get in this manageability space is, hey, how do you evict cache items from DAX? Well, DAX really has 2 algorithms at play. You can set a TTL, or a time to live value for the items that exist in DAX, and after, say, 5 minutes or 10 minutes or whatever is applicable for your application, we'll expire those items. DAX also uses what is called least recently used, which is an algorithm that says, hey, if your application is just pounding your DAX cluster, which items do we evict? Well, we'll evict the ones that are least recently used in favor of the ones that are most recently used. And DAX also we deploy within your VPC, so we provide that strong network boundary between your application and the caching tier. So as we've been working through the beta with quite a few customers, there's been 2 use cases that have really emerged. The first one is customers that have, as Jim was talking about, really unpredictable workloads. And what typically happens in databases, and what customers do a lot, is they over-provision their database significantly because the chance of not hitting your customers on Game 7 of the World Series is very detrimental to your business. But it also becomes pretty expensive to over-provision, or it becomes a lot to manage. What customers typically do in those situations is add a cache, right? It's a great buffer. And you see this across an entire application stack, whether it's in the client or whether it's in front of the database. And what we see with customers looking at DAX and DynamoDB together, and I really love these quotes, is the best of both worlds, where I get improved latency, I get the 10x performance or the 20x performance that we saw here, but I also can think about reducing some of my over-provisioning on my database because DAX provides that buffer for me. The second pattern that we've seen emerge is just the customers that want the raw speed. And this goes back to, hey, we're not having a conversation about milliseconds anymore. We're having a conversation about microseconds. And if I can achieve that, that helps me do 25% more work before I have to place a bid, or it makes my game that much faster. I mean, sometimes I'll just go and watch Twitch, and those guys know if there's a little bit of jitter in the game or there's a little bit of latency, those guys call it out on the game and call each other out and say, hey, your connection's not good, or there's a problem with the game. So these things really, really matter. But what has been consistent across the customers that we've been working with in the beta is the ease of use. And one of the gentlemen we've been working with is a VP at one of the companies. And And he has a whole engineering team at his disposal. He can call any one of those guys into his office to help him at any time. And he said, hey, adding DAX to my application was so easy, I didn't need to ask any of those guys for help. So, I just want to, with our customers, I think Glenn, really summarized this, and I don't think I could say it better, so I will actually read it verbatim. And this is really at the spirit of working back from customer problems. Is AWS team has taken a best practice architectural pattern and turned it into something that is repeatable and valuable for its customers. So we see that if customers want to achieve that performance, instead of having every single customer write that bifurcation logic for caching for every single application that they want to use that for, we just made it easier for them with DAX. So DAX is in public preview today. Amazing performance, really simple to use, and we feel, for a lot of customers that have given us feedback, it's actually going to help them not only achieve more performance, but also save costs on their application as well. So thank you.
Great, so we're really excited about that one. I'm going to go through some of the other areas as well. So we talked about security. Well, we talked security is one of the areas we care about. And we care about it again because Amazon uses DynamoDB, and as well as so many customers. We have a number of regulatory compliance regimes that we have to comply with, as well as our customers. So kind of it drives us to always be raising the bar with security. One of the first areas that we have is integration with AWS Identity Access Management, and that gives you the control at the user level, at the federated user level, even using internet identity providers like Facebook and Google or whatever. You can give access control, control it at the user level. And it's also, we have very fine-grained access control at the DynamoDB level. We can support per item and per attribute level access control. So you can really control things down to the equivalent of a single row for a single user. You can also do things like ensuring users can read and write to a DynamoDB table, but they can't do more destructive operations like deleting data from the table or dropping a table. And that's really important as for mission critical workloads. We have monitoring integration with CloudWatch, so you can make sure you're tracking access patterns to your DynamoDB tables. And then we have integration with CloudTrail for audit log purposes. Then we have a wide range of compliance support: SOC, PCI, FedRAMP, HIPAA, et cetera. Now, one of the most common security best practices is to use an Amazon virtual private cloud, which lets you virtualize the network and control, create subnets and control access within those subnets. And before today, that's good for your EC2, but if you needed to access data in DynamoDB, you basically had to manage egress from your VPC subnet, manage an internet gateway, traffic would actually go out to the internet, and your DynamoDB tables were potentially, or they were accessible from the public internet. I mean, you can use access control to lock that down, but in order to make this pattern work, you had to have those tables internet accessible. And today, with the launch of the public preview of VPC endpoints for DynamoDB, we've now extended that so you can essentially extend DynamoDB into your VPC. And with that, the main one, it gives you much more fine-grained control. And then, while having DynamoDB internet accessible is kind of mandatory for use cases like mobile, IoT devices, where you want the internet to be able to access your DynamoDB tables, if you are doing more back office or financial applications or what have you, there you probably don't want your tables to be internet accessible. And so let's walk through how you actually do that. So you use identity access management to create a policy that can restrict users, groups, or roles to a particular VPC endpoint for a particular DynamoDB table or tables. And so here we're going to construct an IAM policy. So first we're saying deny all DynamoDB actions for all accounts except when it's coming from my particular VPC, so that VPC-E-111-BBB22, that's the identifier for the VPC you're using. And so that will lock down access to your table, and again, you can do this for particular users, particular tables, all tables, et cetera. You just have to apply the policies. And the key features here, security, access control, locking off access from the public internet gateways, and it's fast, secure, and easier to use than what you could do prior to today. It's in public preview right now in 8 regions. We're adding more all the time. And so we really look forward to you trying it out, signing up, trying it out, and giving us feedback on it. Great. Okay. Availability and data protection. All customers care about it. We care about it. When we look at DynamoDB, we're available in all AWS regions worldwide, 16 regions and counting. So as you hear the announcements that AWS is adding more regions, I think we just said Sweden, we just announced Sweden just recently, you can know that DynamoDB will be there. In fact, as we are building out new regions, we cannot even boot up EC2 when we're building out a new region until DynamoDB is already up and operational. So what that means to you is you can just rest assured knowing that Dynamo is going to be in all these regions and as AWS expands. And so we're probably already in the regions you need, but you can also rest assured that as your business expands and AWS expands to different regions, Dynamo will be there too. You can see we're already operating at a pretty large scale. And then, of course, we take care of replicating data and making sure the data is available to you by replicating across 3 availability zones for you, all behind the scenes, all within that single-digit millisecond request, so that you can just worry about your app and not worry about your data. Okay. So then manageability. I said earlier, a lot of customers really choose Dynamo, even if they've tried other NoSQL databases previously. We've had a number of customers try NoSQL databases themselves, and then over time at scale, they realize that managing a 50-node cluster or a 100-node cluster, it's hard to do a lot of muck. It requires specialized skill set because you kind of need someone who can kind of think like a DBA, but also think like a developer. And it's a pretty hard skill set to find, retain, and scale, and 24/7 around the clock. And so we have a number of customers that, once things get big, they come to us and say, hey, I think DynamoDB is a better solution for us. And so, previously I mentioned that customers have individual tables that exceed 100 terabytes. And that's pretty cool, but over time that data can really be hard to manage, particularly if you have regulatory requirements that say you have to expire out all data. Or if, in order to keep your application tuned, you want to make sure that you're only pulling back a small result set and you don't want to have to paginate through, you might want to, delete out old data just to kind of make sure that your app response is staying performant. And, you could have done that previously with Dynamo, but it's a lot of muck for you to handle, particularly when you're talking about, terabytes, tens of terabytes, hundreds of terabytes. And so in February, we announced TimetoLive, which is generally available in all regions. And essentially what you do is you specify a single attribute of your table, and you say, hey, that's my TTL attribute. And then you set a timestamp at a per item level. And then Dynamo will, behind the scenes, sweep out the old items and delete them on your behalf as a background process. And what's good about this is it's not at all interfering with your IOPS, your IO, coming in from your application. We just use spare IOPS behind the scenes, and it's all free to you. These deletes are logged to DynamoDB streams, which means all of this gives you the ability to reduce costs. For your application, some people find that shrinking the data set for their app, while Dynamo queries are very consistent. Their application having to paginate through smaller result set can be beneficial. And then we're starting to see customers who, looking at these streams and viewing the deletes that we're doing, since they're all log streams, they're then triggering other workflows, Lambda functions that then are doing like post-processing. So things like, hey, when I delete this DynamoDB record, I'm then going to configure a Lambda function that will then go and delete any associated S3 data that maybe pertain to, say, a customer ID that was in that record, that kind of thing. So it's very extensible, and we're starting to see customers do more like that. And so Tune is an ad tech company. Ad tech companies produce a ton of data, and shortly after we turned them on for TTL, they purged 85 terabytes of data from their tables. They saved themselves over $200,000 per year, while also simplifying their app logic, because they no longer had to worry about kind of doing the sweeps themselves. And again, TTL's free to use, saves you $200,000, win-win. So they were pretty happy with that, and we were too. So another thing about manageability. So when I talk to customers, particularly early on in their cloud migration, but probably even continuing on past that, they typically have two main concerns about going to cloud. One is security. And I talked about all the capabilities that DynamoDB has. We just added VPC endpoints, and so we'll continue to iterate there. But the other concern, other than security, is typically cost. And so I can explain to you how DynamoDB is priced, and it's simple and predictable and all that kind of stuff. And then you can learn SQS pricing and EC2 pricing and all that kind of stuff. But over time, I bet most of you are building real-world architectures like this one, and this one's actually fairly simple. And figuring out how cost plays across all those services over time can be pretty complex. And if you can't understand your usage, that could potentially lead to dollars you didn't want to necessarily spend. So in January, we added tagging support. It's generally available in all regions. And this is similar if you've used tagging with EC2 or any of the other AWS services. It's the same thing. We've added it for DynamoDB. So now you can tag particular tables. And you can do things like tag a table and, for project X or project Y, or dev versus test, or internal business unit A versus B, that kind of thing. Whatever you care about. And then it allows you to sort, in your reports, you can see in the, hopefully you can see that in the graphic there, you can then filter your reports to only show particular tags. And the key benefits here is now you can understand your costs, your DynamoDB costs, but consistent across your other AWS spend as well. And so now you can do things like internal accounting, chargebacks, or whatever to know whether it's project X or project Y that's leading you to spend more on Dynamo this month versus last. And then another thing for manageability, we find that a lot of customers might start out with their own databases, either relational or NoSQL. But over time, they find that managing them just is something, overhead they don't want to deal with anymore. And so more and more, we're hearing them come to DynamoDB. And they're saying, hey, how do I get from there over to DynamoDB? Well, last week, the AWS Data Migration Service, which is a service that's been around for a bit now, which previously has enabled relational to relational migrations. So things from like your historical on-prem relational database, either onto RDS for managed relational, or onto Aurora for even better performance, lower cost. So we've been seeing a lot of success with DMS for those kinds of use cases. But now they added connectors for MongoDB and DynamoDB. So now if you're trying to move whether relational or non-relational data over to DynamoDB, DMS can help you with that. So really looking for feedback on this one. Hope you'll try it out and let us know. And that's generally available. And then last is developer platform. It's basically all of you and the folks you work with. We want to make it easy for you to build awesome apps on Dynamo, take advantage of the scale, performance, the global presence that Dynamo provides, and then you do the innovation on top. Now, this diagram, the diagram isn't that important, but what is important is, you could just think of DynamoDB as a database storing your data, but that's not really how the world works anymore. You really need to think about, well, hey, if I have RFID or IoT data coming in, do I have a database that is in the regions where that would be? That can scale if all of a sudden those IoT sensors start triggering more data coming in at a faster rate. And it's always available because a lot of the IoT devices don't do so well if all of a sudden things are disconnected for a while. And so DynamoDB is increasingly used in that way and is kind of an underpinning to some of the AWS IoT offerings. Then, Werner said earlier, DynamoDB has become the default serverless database. And we're seeing that all the time. Customers wanting to use Lambda functions to do serverless. Also things like Alexa skills development, the natural thing, the natural pattern we're seeing is for customers to use DynamoDB as a database underpinning that. And as well as, I talked about streams enables you to, read off the changes and integrate with other things, whether it be EMR and Redshift for analysis, or your own application, saying, hey, when this record changes, I want to do something on my application. So the main point here is, as AWS keeps adding and expanding the services in our internal ecosystem, we keep, DynamoDB is one of these foundational pillars that all these other services are relying on. And we're going to continue to focus on integrating there for you. So as these services come out, Dynamo's there. But also, one of the major areas of focus for us is we want to figure out how to make it easier for developers, how to integrate Dynamo with your services, applications, and your favorite tools and SDKs and all that. So if you have any ideas on that, we'd love to get more feedback on how we could make DynamoDB easier for developers. And so, just winding down here, we talked about these pillars: scalability, performance, security, availability, manageability, developer platform. We were excited to announce a number of things today: DAX, VPC endpoints, as well as some of the other items like tagging and TTL and the DMS connector. We're excited to add those, and our general process, as you probably know by now with AWS, is continue to iteratively iterate on all these dimensions. So you can expect more capabilities coming out on all those pillars over time. And as Werner said, go code. We love these conferences, getting talking to customers, getting the feedback. We really get stoked to launch new services and getting them into your hands, because we have our own suspicions of where we need to go next with some of these things. But really, what guides us at AWS is the customer feedback. So love you to check these out, try them out: DAX, VPC endpoints, the data migration service. And then give us feedback. Again, DAX and VPC endpoints are in public preview today. Sign up, and we're going to be whitelisting starting tomorrow morning. So with that, thanks for coming, and I'll be up here afterwards. Joe and I will be up here afterwards if you have any questions. Thank you.